Hello, everyone. Thanks for joining. My name is Jesse Albert. I'm the Vice President of Sales for Northwest Electric, a NOR partner based in Nebraska. NOR brings together the world's top electromechanical experts to deliver complete line-to-load solutions that reduce risk, boost performance, and offer unmatched collective expertise beyond any single provider. Another way we provide value is by offering training to our customer base. And today we're excited to introduce Gregoria Hadad from Skylar. Gregorio, from his background in electrical and mechatronic engineering, with nearly a decade in IoT and industrial monitoring, knows plants don't just need more data, they need actionable solutions. At Skylar, he helps plants boost uptime, cut maintenance costs, and maximize ROI by delivering real, measurable reliability value. So with that, welcome, Greg. Looking forward to today's presentation. I'll hand it over to you.
Thank you, Jesse. Good morning, good afternoon, everyone. It's a pleasure to be here presenting with you today. And thank you to the Nowhere Network for allowing me to host this webinar. I'm Gregoria Hadad, General Manager for Skylar. And for those of you that are not familiar with Skylar, we're a remote condition monitoring solution. And our objective is to enhance the reliability programs for our end users, and also in particular for the partners that we work with, of which many of them are Nowhere members. And the name of this presentation, Choosing Partnerships Over Platforms, is mainly inspired on the experience that we've gotten working together in this joint-to-market approach with our partners. So the agenda for today, we will start first with a quick overview on the different maintenance strategies. Then I will dedicate a couple of slides to try to convince you why you should invest in reliability, and what are the benefits of a predictive maintenance approach. Then we'll deep dive on what it looks like to deploy a remote condition monitoring solution such as Skylar in partnership with our Nowhere members. And then finally, we'll close with some success stories that we've had, again, between Skylar and the partners, and how we gave value to our end customers. Finally, we'll have some time for some questions. And here, Jesse, at the end of the presentation, will be collecting them. So in the meantime, if you have any questions on any slide, feel free to introduce it in the Q&A, and we'll make sure to cover it by the end of the presentation. So this slide, again, just to put everyone a bit on the same page. I'm very confident that many of you are familiar already with these terms. But starting with corrective maintenance, this is also known as the run to failure approach. And normally it can look like it's the most cost efficient way of having maintenance. So just running the asset all its possible life until it fails. But it's coming with a lot of hidden costs. There's a lot of unplanned downtime, and there's a lot of expenses on excessive repairs. And there's also another issue, that is the lack of planning and how this affects to the entire workforce environment. Having constant calls, for example, it can happen at 2 a.m. on a Saturday to have to go on the site and fix an equipment, because otherwise the production is not running. Then on the opposite side, we have preventive. And this one is, it basically has a lot more of expenses in terms of excessive maintenance. But the idea is to have as many repairs as possible executed on the equipment so that it continues running. And it also comes with the cost of a lot of downtime, in this case, planned downtime. But this is also coming at of course, as a disadvantage because it reduces the efficiency of our processes. And then in the center, there is predictive maintenance, which is striking the perfect balance between the total downtime and the number of repairs and maintenance costs that we need to face. The reduced downtime, it's mainly because we are able to detect faults in a very early stage in time. Even in some cases, for example, for early bearing degradations with Skylar, we can find them up to 6 months ahead. So this allows us to pack a lot of different faults and address them in, for example, that single outage that we have once a year. And it also reduces the repair costs if we detect a fault early and we act upon it, the cost to repair that is going to be a lot lower than if we wait until we have a critical failure occurring, which could damage a motor and all the driven components that it has. So also the idea of this slide is to also have you think a bit on more or less where do you think you fall as an organization. Then also the challenge to, even if you are on the corrective or preventive side, changing to predictive is not something that can happen from one day to the next. It definitely requires a mindset change, and it also requires data, and it requires technology. And many of you might be familiar, but many of these programs are using as a basis, for example, vibration and temperature. And this is what connects me with the next slide. What has been the evolution of vibration collection in time? So already in the 1940s, there were manual vibration gauges that were used, and they were used actually in the aircraft industry to understand what was the total life remaining for the critical equipment. But the problem that we had at that time was that there was a lack of data. So we didn't have enough devices, we weren't able to collect that data that was in the field. So that's what evolution has been from what I put here as the manual era until we got to the smart era. So we've always been getting better in how to get the data. Then we went to the piezoelectric accelerometers, we had the FFT analyzers, then we had the portable data collectors, which gave birth to the route-based analysis, which is something that many of you might be familiar with and might be using even today. And then we got to the wireless sensors, which made installation a lot easier thanks to the lack of the cable. And then we had the MEMS accelerometers that were a lot cheaper than the piezoelectric, with a very good performance as well, and didn't require the yearly maintenance. So now we got to the exact opposite problem. I think we all agree when we say that there's a lot of data out there. Now we're very good at collecting it. This is something that we've solved in practically every industry. But the problem is, what do we do with the data? So how do we actually make this this data change it into actual information that is going to help us make our decision process a lot more efficient? And this is where AI is coming in and has come in the past years. So it has allowed us to aggregate all this information and being able to get to the actionable insight. So we get all the data now, what do we do next? And this is definitely advancing a lot. It's going to continue getting a lot better on the detection side. But we've also learned in Skyler that there's the human factor that AI is not able to get still today. And this is something that through our Nowhere partners, we are being able to get that extra layer by also going into the field and being able to perform, for example, additional tests to the equipment. They normally know the equipment from their customers inside out. They know their processes. So all that additional information that we can get by adding the human factor is something that is making the solution of Skyler different to others. Then I also wanted to spend a slide to show why vibration. Why aren't we using another type of variable? And there's definitely a lot out there that can be used. But I wanted to have an overview on the PF curve. So this is basically on the vertical axis, we have the performance, the health state condition of the equipment, and how just with normal operation, with time, it's getting degraded and failing. So on the left side, we have the normal operation, and the idea with preventive, by performing this normal maintenance schedules, we expect to keep the normal operation, but we also run the risk that if there's any underlying fault that is developing and that we haven't considered it as part of the parts that we are changing during our normal schedule, we could anyways have an unplanned fault. And then on the opposite side, when we already get to fault territory, this is already when the solution, the asset is at a state in which an imminent failure will occur. At this point, we can find it with our senses. We can either see that the asset is not operating correctly, we can hear it, We can feel it by touch with a very high temperature on the bearing, but at this point, it's already too late. So any fault that we find here would definitely be a permanent fault in the equipment. So by using, for example, vibration data for enhancing our reliability program, we are being able to find this fault still at a very early stage, which again allows us to perform the planning for the different maintenance actions, and also at a time that we can fix it and make sure that the damage will not be permanent. So like that, we can also enlarge the life of the equipment. So I'm hopefully doing a good job there to trying to convince you to go to predictive and to invest in reliability. And if I yet haven't, I'm really hoping that this slide will help you see where is actually the benefit on the predictive approach. So this is a slide of with the results of a survey that was done by IoT Analytics, which is a very respectable consultancy company in the IoT sector. And they've done an interview to a survey to over 1,000 people from plant managers, maintenance managers, reliability engineers. And the question was, have you experienced any outages on critical equipment, and how often? And 69% of them said that at least once a month they had a critical an outage only on critical equipment. And the median cost per hour, depending on the industry, was around $1,024 per hour. And we know that normally on critical equipment, this can take us, if we're very fast, between 4 hours and up to weeks if we need to procure the parts. So here's definitely the cost that we can start reducing with reliability, which you can tell me at the same time that it also requires an investment to set up a reliability program. But we will see then with some examples how the ROI of investing in reliability turns positive very fast. Because today we're having these costs hidden somewhere, which can be, again, by excessive repair costs. It could be due to accruals for safety issues, insurance due to lost production. So it's definitely somewhere. These expenses are happening today, and reliability will help you reduce them. So then now I'm going to the next part of the presentation. So I will go through what does deploying a remote condition monitoring solution look like, and specifically for the case of Skylar. Starting from the left side, what we do in Skylar is first the installation of the sensors, so vibration and temperature. And these ones are, when we install them, we locate them as close as possible to the bearings of the equipment. This is because the root of the vibration is coming from there. So as close as possible to them. Then we're normally in Skylar, we monitor an asset, and we consider the asset to be the electric motor plus everything that it is driving. So if it's a motor with a gearbox and a bucket elevator, for the algorithm, for the AI, all of that is the single asset, and it will be looking at all the sensors that are on it to identify a fault. Then once we perform the installation, the sensors are connecting to a gateway. This gateway does not require to be connected into your local network. It can work. It works with an external SIM card, and then it connects via cellular connectivity and sends the data to our cloud. If there would be a case in which you would be interested in getting that data directly in your systems, it is possible as well to use the network. But normally, most of our customers prefer to have that Skylar has an external connection. So then the data is sent to our cloud. It is analyzed with our algorithm. And if we find any type of fault, it is immediately notified to the Skylar vibration analysts and to our partners vibration analyst, and as well to the end user if they desire to. And finally, we have a web-based platform where all the information is displayed. Then we also say in Skylar that we are an end-to-end solution, because we have the ownership of the entire stack. So the sensors are from our property up to the cloud itself. We say we're expert-led because we have Cat 3 certified vibration analysts that have been developing this algorithm for over 10 years, and they are continuously working with our team of data analysts to improve it. And these vibration analysts are going to be working together with you whenever we find a degradation, they will be sending additional reports with detailed analysis of what has happened and what are the next steps that we need to take with the actionable insight. And finally, we say it's an easy solution, and I'm not talking about the user interface, but it's about how we set up the entire program. So on one side, also for our hardware will be the wireless version of plug and play. So the moment you connect give power to the gateways, turn on the sensors, everything is immediately configured. There's no need to perform any other manual task. And the way we work, we also make sure that this is not another system that you need to maintain. Skylar working together with a partner, we want to make sure that we're maintaining the system for you, and are only going to hear about Skylar when a problem is detected, when there's a fault that we find in your plant, and we will tell you what's the next action that needs to be executed. Then related to what I was mentioning before, it's to set up a reliability program. We want to make sure as Skylar and together with the partner that we are spending, that every dollar that is being spent is going to give you the most value. And this is why we offer different tiers of protection with Skylar. The idea is to give you the flexibility to right-size the investment across the entire plant. I will start actually from the right with the Skylar warranty. This is our top tier offer, which has the full-blown data, the full-blown analytics, and it has the vibration analyst support. The data that you're going to get is going to be the full frequency spectrum, raw time data, acceleration, RMS, vibration, velocity. So everything that can be provided will be there in the platform. And on top of that, it has an insurance for unwarned fault repairs that Skylar should have detected for up to $100,000. In the 10 plus years that we've been in operation, we've never had to pay a single claim. So just to give you the confidence that the solution works very well. Then we have Skylar Full, that offers the same number of features as Skylar Warranty, just without the warranty. And finally, we have Skylar Lite, which is a solution that has a threshold-based analytics. It's offering a lot more data compared to, for example, conventional routes. And it can be a very good solution for balance of plant equipment, or there can be, for example, plants that have already vibration analyst Cat 2, Cat 3 certified in-house and want to use it as a DIY solution. This could be a very good proposal as well, since it's automating the data collection that maybe is done today via routes. It's already pre-processing the data. So out of 100 assets that you have in the plant, it's already telling you if there's 10, 15 that have a fault, so you can focus your resources on those. So it can be definitely a good solution for that type of user. Then when we are defining which are the best, what is the best tier for which asset, we perform a criticality assessment through Skylar and the partner. And normally what it looks like is that we have around 5 to 10% of the equipment that makes sense to be monitored with the warranty solution. Then we can have from 10 to 70% that can be monitored with full. And then the remaining with light or another option is also to continue with the route-based monitoring, for example. And then there's going to be a smaller portion that maybe it's not critical to your production. The cost of repair is not that high, so it doesn't make sense to invest in monitoring. And this is definitely something that sets us apart from other programs where the idea is to throw sensors everywhere. We want to make sure that every dollar that you're spending in the reliability program is going to give you back as much as possible. So the way in which we go to the market, as I mentioned before, it's Skylar being the technology provider. So we have the sensors, the cloud, we have vibration analysts in-house. And then we've learned that the best way is also to have boots on the ground to be able to maintain the solution, install it, And this is what the knower member is doing. Not only those two activities, but also having vibration analysts in their team, and they are able to perform also additional reliability services. For example, the moment Skylar can find a detection, the knower member is able to go inside and review the equipment and understand if maybe we need to perform motion amplification, thermography, oil analysis, or any other activity. So that really helps us and the Skylar algorithm as well to get an entire holistic approach to make the detection, understand what's the root cause, so that we make sure that this is something that will not happen to you again. And also, the majority of the knower members are maintenance or repair organizations, so they can eventually perform the maintenance. So we can close the loop for the maintenance action. And the idea, again, is that this solution is as simple as possible to the users. So we don't want you to spend time, we don't want you to introduce another solution that is going to be a problem for you. And that's why the knower member in this case is taking care of all the installation, all the maintenance, and making sure that when you get a report, when we find a detection, you don't have to spend hours going through the platform and trying to understand what to do next. With that reporting, that's the moment in which you will hear from us when the fault is found, and we're going to make sure that we have the clear fault classification and the next steps that you need to take to get your asset back and running. So once we have done the criticality assessment and we know what are the number of assets that we want to monitor, sometimes maybe the criticality assessment is not done, and there are some customers that already know which asset they want to start with. So whichever is the case, once we know what we're going to where we're going to install, this is the process that we follow. The first step is what we call the site survey, and what we're doing here is getting all the metadata of the equipment. So we're going on site and collecting the information that's on the nameplates. So all the technical specifications, such as horsepower, what's the RPM that it's going to run at, what are the bearing numbers. And what this will do is to give the context to Skylar of what we are monitoring. Because otherwise, without it, the system doesn't know if it's monitoring a 150 horsepower pump or if it's on a washing machine. So this is a critical step that we perform at the beginning of every before every installation. During the site survey, we're also going to check what's the connectivity. So we're going to check there's power for our gateways and that the sensors can connect to it, and also that the cellular connectivity is available. So once we have done all these activities, and we've also determined what's going to be the ideal location for the sensors, we go with a finalized list. We get the approval from the end user, and then we go to the next phase. That is the installation, which consists on mounting the equipment. One very relevant thing that we take very seriously is the surface preparation for the sensor. So this is critical for the long term and the quality of the data that we collect with a sensor. The surface has to be clean accordingly, and then we use a mounting accessory and epoxy to keep the sensor fixed. Then after that, once all the equipment has been installed, that's when we start collecting the data, so immediately after, and the system can already start detections, and it's also starting what we call the analytics learning process. This can take around a week, and with all that metadata that we collected and the information that it's coming in, the system is able to tell if the equipment is healthy, or if it is already degraded, or there's a fault under development. So once all that analytics learning process is over, then we can say we are already in what we call the use and support phase. So that's the normal usage, and that's when we're going to be, you might think that's the moment in which Skylar is outside and you're just using the platform. But no, that's the moment in which we are as close as possible to you. Here, the system is going to be, this is an overview of our platform. So you will have in the asset list the classification for the different health states, and the priority is going to be given to that one that's the most degraded. That's what you can see in point number 1. Then when degradation is detected, steps 2 and 3 happen practically instantly and simultaneously. So you end the platform, you're going to see a recommended action and a description of the fault, which will then be also reviewed, and complementary information will be added by our vibration analysts. And there's going to be the notification that you get to your email, which is going to tell you what is the asset that is affected, what is the component, meaning is it the motor driven end, or is it the fan non-driven end? What is the observation that for which the anomaly was triggered? What is the fault classification? And already recommended next steps. And then there's going to be step number 4, which can happen the same day or a couple of days later. And this is the report that will be sent by the vibration analysts from Skylar and from the partner. So this one is going to have similar information to what you received in the email, but with a lot more detail of what has occurred. And we normally have a cadence which can be once a week, once every 2 weeks, or once a month, depending on the amount of time that you can dedicate and the number of assets. And in this one, we will discuss about the different reports that were found. And it's also time for you as consultancy directly with the vibration analysts. So this was an overview of how we work together with the Knower partners. Now, I want to show you some success stories that we've had with them. This first one has been with HECO. And this was specifically at a peaker plant. And this was a customer that was performing routes for the last 20 years with HECO. And we had the issue that specific piece of equipment, there were around 6 motors. They were starter motors. And since it was a peaker plant, they could start at any time in the day. And they would run intermittently between 15 and 30 minutes. So it was impossible to program this a specific time for the vibration analyst to be there and collect the data. So we at Skylar, we worked together with them to solve this issue. And by fixing our algorithm, we were able to add a new feature so that we could detect when the equipment was turning itself on, and we would trigger 4 or 5 data collection samples in around those 30 minutes that it was operating. So we've recently were able to find a fault with this motor, and they're looking at what are going to be the next steps. But definitely this was an asset that they weren't able to put into their reliability program. And with a solution like Skylar, we're able to keep an eye on this one. Then the next one is at an aggregates facility. This was a cavitation that we detected in a pump. And what was really cool about this story was that they had 2 pumps operating, 150 horsepower, and they were normally using one, and the other one was a redundancy. And we found an issue in the motor of one of the pumps. So at that point, they wanted to wait until the next outage. So they switched and started working with the second pump, which very soon we detected that it had signs of cavitation. And the reason was that they hadn't done the maintenance for cleaning those filters for a very long time. You can see over there, there's marine life practically in there. So they were able to, in just 2 hours, they were able to switch back to the other pump that still had remaining useful life. We were able to clean this pump in just 2 hours, and then they switched back and put it back and running, and then they were able to fix the other equipment when they got their outage. So by working, we normally work with this customer to understand what's the ROI that we're providing them. And the way we calculated these savings that you see here, $55,000, is that they had an issue in the past similar with this pump 2 years ago, actually. And they took them 12 hours and a replacement of the entire pump for that specific cost there. So, and this was something they avoided thanks to Skylar. So then the next one is in a cement plant. where we had a looseness. There was a looseness detected in a bearing. And you can see here the graphs, actually. If you see point number 1, that's when we detected the problem. We notified them. And we were lucky that there was an outage coming in a couple of days later. So you might see here, that's when the equipment went off. They were able to fix the issue. They were just actually tightening a bolt from the base that was not that was loose. And as soon as they started again the equipment, this was around March 3rd. There's the point number 2. So the equipment started operating again. The numbers, the vibration was pretty normal, but then just a month later, you can see in point number 3, we got back to the same levels as point 1. And so we were able to tell them that we got to the conclusion that there's another problem here. It's not just a specific looseness. There's something going on at the base of the equipment. So we also sent people on site, and we were able to find that, as you see there, the base of that motor was not fully attached. So the customer, in point number 4, they were able to hold it running. This was a kiln cooler fan, by the way, so it's a critical asset for the operations. But they were able to put other equipment running, and they prepared, basically, they had to make a new base. So the point here with Skylar has been that not only was able to detect a fault, but it's also able to tell you if the maintenance, you can assess if the maintenance was done correctly. And for this specific case, we calculated the savings similarly to what I mentioned before. This had been an equipment that presented problems in the past, and looking at the base, we were able to tell why immediately. There was a savings of over $62,000. And then for the last slide of the deck, this was a more holistic approach, which we got with another cement plant. And what we did with them here was to, at the beginning of the program, already understand what were the objectives, what were they expecting to find or to solve with a solution like Skylar. And they told us that the most important for them was to improve the kiln efficiency. And we understood they also understood that Skylar can help with the mechanical faults, but there could be other things also that are impacting the kiln efficiency. So we went down to also analyze in time what were the unplanned downtime events due to mechanical faults across the entire plant, and then which were those, again, that were specifically on rotating equipment. And we were able, so they installed Skylar in February, and in just a couple of months, we were able to bring, together with many other initiatives that they were following, but Skylar as a key contributor, we were able to bring the efficiency almost up to 90%. And we're expecting that this will happen in the next month. And for awareness, this is a plant that has a revenue of over 50 million. So just by increasing 1% that efficiency, we're talking about, if this is sustained in a year, we're talking about $500,000. So this is, and then in going to the next one, we were able to reduce almost 50% the total mechanical faults that had occurred across different pieces of equipment. And then specifically for the rotating equipment, for the critical rotating equipment, we practically brought the faults to 0. And all of those that you are able to see here in the months of March, May, June, those were all an equipment that was not currently monitored by Skylar. So in all the equipment that we had been monitoring, we were able to eliminate the faults completely. And in just 3 months, the customer was able to get a positive ROI on Skylar. And in 6 months, we got to over 300%. So they basically paid for the entire program in 6 months for the next 3 years. And well, this was the last slide of the deck. And well, before handing it over to you, Jesse, I just wanted to provide 2 unsolicited recommendations. The first one is that if you're thinking of starting a reliability program, I would definitely recommend to start small, start with pilots, try many different solutions, and so that you can make sure that they are meeting your expectations. Because there are many solutions out there that maybe can offer something for extended periods of time with very high volumes, and then you might find after a couple of months that you're testing it that it's not the best fit for you. And the other one is that something that we've learned with Skylar is it's very useful when there's an external set of eyes that is supporting you in building the reliability program, someone that has already done it in the past and also has the advantage of knowing your equipment inside out, knows your processes, speaks the same language as you. And that's why in Skylar we always work with the nowhere partners and having partnerships that are very strong on the reliability side. And this is why of the name of this presentation. So choosing the right partnership over the platform is definitely going to help you to get the highest ROI for every dollar you invest in an initiative like this.
Awesome. Thanks, Greg. We got a few questions that have rolled in through the chat. So first one is, how are you preventing false negatives?
Well, so that's definitely part of something we've done through the algorithm. And we also have support there with the vibration analysts as well. That are giving a review also on the fault immediately and make sure that you're getting the right alert.
Outstanding. Next question is, what is the maximum sample rate on your devices? How does that change with subscription?
So we're doing with the full version, we're doing 4 times a day. And with light, we're starting at once per day. We can have flexibility on that, but let's say that's normally the basis. And if you compare it with, for example, a route program where you're getting maybe data once a month, if you think already getting four times a day, high quality data, getting the raw time series, the entire spectrum, this is already more than enough to have a robust reliability program and find faults with many months ahead.
Very good. Next question, also from Scott. What are the limitations of your hardware frequency?
So the cutoff frequency, it's at around 6.4 kilohertz. And our sampling rate is at around 27 kilohertz.
And then finally from Scott, what is the classification rating for the hardware? Class 1, Div 1 is the question.
So our sensors are Class 1, Div 2, and the gateways are not. But if we are able to find, we're working on actually having a solution that's fully Class 1, Div 2. But if we are able to find a location from the gateways to the sensors, where the gateways outside of that area, we can make it work. And another not asked, but in line with that, the line of sight that we have tested with between the sensor and the gateway has been as much as around 200 feet.
Next question, what are the risks to the existing system? Can this shut down motors without the team on site approving it or cause IT vulnerabilities?
So on the first point on the protection, so Scalar is not shutting down anything. It's completely external to your network. So the idea is that this is a predictive solution. So you're going to get the alert, and it's not going to be something you need to shut down immediately the equipment. The idea is that we give you sufficient time to plan accordingly for the next outage that you can have a month, 2 months ahead. So to answer the question, no, it doesn't turn off the equipment. And the idea is, again, that we warn you with a lot of time ahead. And there was another part of the question there, Jesse.
Yeah, 1 second. Let me go back to that screen.
There was about the IT. So
yes,
we don't need also connection to the IT. We can be completely external. So we have a SIM card just like your cell phone that is put in the gateways, and they're connecting outside of the network directly back to our cloud.
Another question from Michael says, a FFT algorithm can detect the first and second order harmonics preemptively, showing bearing fault. What additional information does AI analysis provide?
I would need to check that actually with the VA team. I can get back to you via email on that.
Very good. And then what happens in case of sensor battery dying or other issues? Are sensors covered under warranty?
So we cover the warranty for the battery up to 1 year, but the minimum lifetime that we've had with the sensors, it's been at least 3 years. And normally, how we work with our partners when they're supporting it for you, they're going to take care of the hardware. So if there's anything that needs to be replaced, Skylar will respond to it, and you will be working with already with a fixed fee every year. So covering already the hardware.
Those are all the questions. Oh, wait, we've got one more coming in.
I saw it's regarding submersible pumps.
Yes. Could I use the sensors on submersible pumps?
So if the sensor can't be underwater, but not because the IP rating is not enough. So it's actually because the connectivity, the signal itself, it cannot be transferred through the water. That's the actual problem. But if there's a pump in cases that at least the motor is visible and one of the bearings, we can at least monitor those.
Any other questions, guys?
Looks like it's all.
Everything for now, Greg. One more. If an asset's being monitored and the motor is switched out, then what happens?
But so switched out if it's replaced. Well, in that case, the sensors are mounted on an accessory, so they can be easily unscrewed and removed. So the asset can be taken out, and then eventually we can install it on the new piece of equipment. So we would need to, if we've changed it for a new motor, we're going to have to perform the installation of the accessories again, but then we can use exactly the same sensors, and the system will be keeping all the data also from the previous equipment in the platform. But we also need to be notified of that. That's something that our partners are going to take care of. But it's definitely something that we put in the platform to note as well when that repair was done, what was done, and the reasons for which it was removed.
Very good. One more from Scott. What are the temp limitations of the battery?
Okay, that's a good one. It's 185 Fahrenheit for the sensor. And I would need to check in Fahrenheit how much is minus 40 degrees Celsius. But yeah, those are both ends. Anything else? Well, in case guys, you have any other questions, feel free to reach out to me to mobile, email, and you can also visit our website and also leave us any type of requests in there.
Awesome. Thanks, Greg. Appreciate the information. And if there's any other questions, let us know. Otherwise, thanks everyone for joining today.
Thank you so much, everyone.